In this lesson, we're going to wrap up section 4.7, part 2, which deals with writing a linear equation given various pieces of information and writing that equation in whichever form asked. Now at this point, we have learned now all three forms of a linear equation. Most recently, in 4.7, we started with point-slope form. The equation y minus y1 equals m times x minus x1, where m is our slope and our x1, y1 are the x and y values of our point. Slope-intercept form of a linear equation is the main type of linear equation that you will see most often, and people like that the most for whatever reason, and that is y equals mx plus b, where slope is m and the y-intercept is b. Keeping in mind that the y-intercept is the location where the line crosses the y-axis. Slope-intercept form is easiest in terms of seeing different pieces of information and potentially graphing as long as the numbers work out nicely, but we definitely need to make sure that we're familiar with all three. We then have the standard form of a linear equation, and that's ax plus by equals c. So x and y are together on one side of the equation with the constant on the other. Technically, a and b both can't be 0 because if they both were 0, we would not have any variable. So for big picture, in order to write an equation, we need slope and a point. Sometimes you'll be provided with the information that you need in order to write the equation as specified, and other times you need to do some additional work. So, if you have slope and just a plain old point, not a special point, just a plain old point, it would make sense to use point-slope form of a linear equation in order to write our initial equation. We can always transform equations if necessary. Now, if we have more specifically a slope and the special point known as the y-intercept, well then we would definitely go to slope-intercept form first. So either of these, we can go straight to an equation and then rearrange if we need to. Now the problem is, if you're only given 2 points, we must find our slope first. Okay, using our slope formula, y2 minus y1 over x2 minus x1. And then we can use technically either one of the points to either write our equation in slope-intercept form, solve for b, or go into point-slope form, which to me makes the most sense. So let's start with number 1. It says write the equation that describes each line in slope-intercept form. Okay, so ultimately we want slope-intercept form for our final answer. So I'm going to show you 2 different ways of doing this. When I personally look at this information, we have slope, which is known as m, and we have an ordered pair. Okay, so we have a point. So it's x of my first and only and y of my first and only ordered pair. So because I have a slope and a point, or a point and a slope, I would start off with point-slope form. And remember, point-slope form is y minus y1 equals m times x minus x1. And we substitute m, x1, and y1 in to our formula. Okay? So that would mean our equation will say y minus my y sub 1 is 4 equals m, my slope in this case was 3, times x minus x1 is negative 1. So x minus negative 1. Close it up. Now, technically, this is point-slope form. I don't like how that came out here. So because it's point-slope form, we need to make sure that we transform it into slope-intercept form as asked. I didn't change my colors either. Okay, so we have y minus 4 equals 3 times the quantity x minus negative 1. So two things need to happen. First of all, the minus negative becomes a plus positive. Okay, so if we want slope-intercept form, that means we need to get y by itself. So first I'm going to take this 3, distribute it through to get rid of the parentheses. So now it says y minus 4 equals 3x plus 3. And now we isolate y by moving the minus 4 by adding 4 to both sides. And notice I'm going to stack the 4 right underneath 3 because they are like terms. So our slope-intercept form of this equation is y equals 3x plus 7, where our slope is 3 and our y-intercept is 7. We could have also said, okay, we want slope-intercept form. Okay, that's what the problem asked for. So I've got m, an x, and a y, so I need to find b. Okay, so let's go that direction for this way. So let's start with y equals mx plus b. And slope-intercept form equations have a y and an x in them for their final answer. So let's start by just substituting the information that we have. So my y value is 4 equals my m value is 3 times my x value is negative 1. And I don't know b, but I need to find it. So 3 times negative 1 following PEMDAS is negative 3, so 4 equals negative 3 plus b. And in order to isolate b, we would add 3 to both sides. So 7 equals b. Well, if 7 equals b and my slope was 3, I do have my slope-intercept form of the linear equation by just plugging into y equals mx plus b now. So y equals m is 3 times x plus my b of 7. Okay, so you do, in theory, have options. Okay. Number 2 says to, again, write the equation that describes each line in slope-intercept form. So in number 2, all I have is 2 ordered pairs. So I'm going to label them because I need a slope in order to write an equation. X sub 1, y sub 1, x sub 2, y sub 2. And remember, our slope is y2 minus y1 over x2 minus x1. So my slope in this particular instance is y2 is 1 minus y1 is negative 3 over x2 is 4 minus x1 is 2. So 1 minus negative 3 means 1 plus 3, so that gives us 4 in our numerator over 4 minus 2 is 2 in the denominator, which gives me a value of 2 for my slope. So now I have a point. Well, I technically have 2 points, and I have my slope. So I can either take slope-intercept form and find b, or I can write in point slope form and then rearrange. So because the problem is saying specifically write the equation in slope-intercept form, let's just go with y equals mx plus b, substitute in and find b. Okay, so but we do have to make sure that we're careful. We have an x and a y, so we have to plug in these and our 2 for m, and then find b. So y, I'm going to use my first ordered pair. Y is negative 3 equals, my slope is 2 times my x value is 2, drag down the plus b, which we're going to find. I have to now do my PEMDAS 2 times 2 is 4, so I have negative 3 equals 4 plus b. And I would get b alone by subtracting 4 from both sides. So negative 7 equals b. So now I have my m, my slope, and I have my b, my y-intercept. So now I can write my equation, y equals mx plus b. So y equals 2x minus 7. Okay, so I do think that in order to avoid confusion and give you just one direction to go, if it tells you to write an equation in slope-intercept form, start with slope-intercept form, okay, and plug in the information as you know it, okay? And if you don't have a y-intercept to start, that's fine. You just plug in x and y. All right, so let's take a look at number 3. Number 3, we've got an x-intercept of 1/4 and a y-intercept of 1. Now, this y-intercept is technically our b value. Which is great, but we need to find m. We always need a slope. Okay, so must find m. Now, technically speaking, because I have an x-intercept and a y-intercept, I have 2 ordered pairs. So my x-intercept is the ordered pair 1/4, comma 0. My y-intercept is the ordered pair 0, comma 1. So I can plug into my formula my y2 minus y1 over x2 minus x1. Okay, so with my 1/4 0, I've got x of my first, y of my first, and then my 0, 1, I've got x of my second and y of my second. So when I plug in, y2 is 1 minus y1 is 0 over x2 is 0 minus x1 is 1/4. So my numerator is 1. My denominator is negative 1/4. Well, if I have 1 divided by negative 1/4, if I write that now horizontally, when we divide with fractions, we multiply by the reciprocal. So this is equivalent to saying 1 times negative 4 over 1. Therefore, my slope is negative 4. Now, you could also type this into your calculator and it'll clean it up for you. But now that I've found my slope using these technically 2 points, I'm going to use my y-intercept and my m in order to write into y equals mx plus b. So this equation will say y equals negative 4x plus 1. Number 4, we have a slope of 1/3 and contains the ordered pair negative 3, 1. We want slope-intercept form, so we're going to write slope-intercept form. And I do have slope, so that's good. But the thing I don't have is the y-intercept. So I'm going to put my 1/3 in for my slope, and I'm going to put the negative 3, 1 in for my x and my y. So that means my equation now says at the moment y, which is 1, equals m, which is 1/3, times x, which is negative 3, plus b, which we don't know. Okay, so must find b. So when I clean this up, 1/3 times negative 3 is negative 1. So I've got 1 equals negative 1 plus b. So I get b alone by adding 1 to both sides. So 2 equals b. So now I have my y-intercept, I have my slope, and I can go directly to my slope-intercept form now. Y equals 1/3 x plus 2. Number 5, if we want to write an equation in slope-intercept form, we always need a slope. Okay, we need a slope in some form of a point. So right now I don't have slope, so I need to start by finding slope. Okay, so find M. So I'm going to label x1, y1, x2, y2. You go ahead and find the slope using our slope formula of y2 minus y1 over x2 minus x1. So hopefully we got a slope of 6 because we had 10 minus -2, which gives us 12 in the top, over 3 minus 1, which gives us 2 in the bottom. We simplify to get a slope of 6. Now we have slope, but we want slope-intercept form, and I have some points, but they're not specifically the intercept, so I need to find B now. Okay, so I'm going to start by writing y equals mx plus b. And I'm going to plug in using my first ordered pair just to keep a routine. Always use your first ordered pair if you're just plugging an x and a y in order to find b. So my y is -2 equals m we found to be 6 times x we found is 1 plus b. So when we PEMDAS, 6 times 1 is 6, so -2 equals 6 plus b, and get b alone by subtracting 6 from both sides. So -8 equals b. Now that I have my slope and my y-intercept, we can write our equation. Y equals 6x minus 8. Okay, people like slope-intercept form just because it helps us in terms of real-life situations, starting amounts, and rate of change. In terms of graphing, we have a starting position, a y-intercept, and then a slope to be able to rise and run quite easily. Okay, but sometimes we just need to take our time and stop and think. Now, 1 to 5 all were slope-intercept form. The next 2 examples ask us to write an equation that describes a line in standard form. Okay, now, no matter what, we need slope. Okay, so let's start there. Currently we have 2 points. Okay, let's find slope. So this is x of my first, y of my first, x of my second, y of my second. So my slope, y2 is -3 minus y1 is 15 over x2. Try to straighten out that line here. Over x2 is -4 minus x1 is 2. So that gives us -18 over -6, which simplifies to +3. Okay, so our slope is +3. So because it wouldn't be a bad idea to practice using slope-intercept form to start, the thing is, with standard form, I need to know what's in front of x, what's in front of y. I need to start somewhere, and right now all I know is m. So let's go ahead and we'll start with y equals mx plus b. And I'm going to use my first ordered pair and my slope, just like I did in the previous problems, to fill in to find b. Okay, so y is 15 equals 3 times x, which is 2, plus b. So 3 times 2 is 6, so we have 15 equals 6 plus b. And then when we subtract 6 from both sides, we have 9 equals b. So as long as you write a legitimate equation in one form, you can transform it into standard form very easily. So let's start with my m of 3, my b of 9, with y equals 3x plus 9. Now, standard form means put each of the x's and y's, put the x's and y's together on the same side. So that means I'm going to take this 3x, I'm going to move it to the left by subtracting 3x from both sides. So my new equation says negative 3x, it's technically a positive y, so plus y equals 9. Okay, now technically speaking, we could have gone the other way. We could have moved the y to the right and the 9 to the left. So completely opposite answers would also work. So a positive 3x minus y equals negative 9 would also be equivalent if you chose to move the y to join the x. Okay. Number 7 is the same exact type. Okay, so we're going to find the slope first. And then we'll write our equation first in y equals mx plus b form, our slope-intercept form, before transforming it. So you go ahead and find the slope again, using y2 minus y1 over x2 minus x1. All right, so our slope here should be negative 1/5. We've got negative 2 minus negative 3 in our numerator over 5 minus 10. Negative 2 plus 3 gives us 1. 5 minus 10 is negative 5. So our slope is negative 1/5. I now want you to take this slope and our first ordered pair and start by writing your equation using slope-intercept form. So we're going to plug in for x, y, m, find b, and write your equation in slope-intercept form. So after plugging in 10 for x, negative 3 for y, and negative 1/5 for m into y equals mx plus b, hopefully you found that b is negative 1. So we now take our y-intercept of negative 1, our slope of negative 1/5, and plug it into y equals mx plus b. Now, remember, our final goal is to write our equation in standard form, which means x and y need to be together on the same side. So our final step in order to accomplish that would be to simply add 1/5 x to both sides, because currently it's a negative 1/5 x. Which gives us a standard form equation of positive 1/5 x plus y equals negative 1. Our old version of standard form used to state that all of our coefficients for x and y needed to be whole numbers, they needed to be integers, and x needed to be positive. So if you're looking at potentially older type of practice problems or worksheets or literature, as far as math is concerned, we wouldn't even want this to be a 1/5 in the front. So in order to get rid of the 1/5, if I multiply by what's in that denominator down here, if I multiply the whole equation by a 5, everything will now be whole numbers. Okay, so we didn't like fractions or decimals before. So if I multiply everything by 5, that would give me 1x plus 5y equals negative 5. Okay, because 1/5 times 5 will give us 1x. Okay, so kind of depends sometimes on different scenarios every now and then. People kind of like to view rules differently or go back in time or different things. So just something to be aware of, okay, in terms of standard form. But as far as I'm concerned, I am okay with this. Okay, however, if it's a multiple choice type problem, you need to also be aware that this second line is the same as the first line. It was just take the first one and multiply it by 5. Okay, so let's take a look at number 8. It says the cost to stain a deck is a linear function of the deck's area. The cost to stain 100, 250, and 400 square feet are shown in the table. Write an equation in slope-intercept form that represents the function. Then find the cost to stain the deck, whose area is 75 square feet. Okay, so we need two different pieces here to ultimately give our final answer. So first off is I need to write an equation in slope-intercept form, and I technically have ordered pairs here. Now, I'm going to avoid the decimals, and I'm going to take the first ordered pair, 100, 150, and my second ordered pair, I'm going to use 400, 525. Okay, you can use any two ordered pairs that you want if you're given more than two. So I'm going to label x of my first, y of my first, x of my second, y of my second. And to write an equation, I need slope. So let's follow our slope formula. M equals y2 is 525 minus y1 is 150 over x2 is 400 minus x1 is 100. So that's giving me m equals 525 minus 150 is 375 over 300. And if we take that and put it in our calculator in order to simplify, 375 divided by 300, well, both of them can be divided by 25. So 375 divided by 300, that gives us 5/4. Or 1.25. Okay, so technically, I guess the 375 and 300 can be divided by 75. If we simplify it manually, we'd have to continue simplifying as far as possible. Now remember, generally speaking, we like slope written as a fraction if we're graphing and things like that. However, in terms of word problems, sometimes decimals are going to be more appropriate. Okay, so here's my slope. Now, I want an equation in slope-intercept form. I found my slope, so let's write what slope-intercept form is. So y equals mx plus b. And I'm going to use my first ordered pair for my x and my y, and my slope of 1.25. Okay, because remember, b is the y-intercept, so that's the ordered pair. X is 0, y is something, or it's just a straight up starting amount when it's presented in a word problem. But I don't have a straight starting amount. Okay, so y is 150 equals m 1.25 times x, which is 100, plus b. When I clean up my 1.25 times 100, I have 150 equals 125 plus b, and isolate b by subtracting 125 from both sides. So 25 equals b. So my equation in slope-intercept form is y equals 1.25x plus 25. So there is the answer to the first part of the problem. Now it says to find the cost to stain a deck whose area is 75 square feet. Well, what variable is area? Well, if I'm talking about area is 75, if I look at my formula, or not my formula, my table here gives me my x's and y's. Area is x, y is cost. So that means 75 is going to go in for x in our equation. Okay, so we're going to do y equals 1.25 times 75 plus 25. So that gives us y equals 1.25 times 75 is 93.75. And add the 25 gives us a y value of 118.75. Okay, so we need to write that in some sort of statement. So it costs $118.75 to stain a 75 square foot deck. All right, and our last problem for this lesson. At a newspaper, the cost to place an ad for 1 week are shown. Write an equation in slope-intercept form that represents this linear function. Then find the cost of an ad that is 21 lines long. So we want an equation in slope-intercept form. And then we want to answer the cost for 21 lines. So start off by finding the slope, because for every equation that we're going to write, we need to find slope. So you pick 2 ordered pairs, whichever 2 you want to. Label them, pull them out and label them x1, y1, x2, y2, and use your slope formula, y2 minus y1 over x2 minus x1, to find the slope. Okay, so after substituting into our slope formula, I used the first 2 ordered pairs, but regardless of which 2 you used, you should get the same exact thing, where our slope ends up being 4.5 over 2, and especially when we have a decimal within a fraction, definitely do the division and write your slope as a decimal in this case. Okay, so 2.25 is our slope. Okay, so that would imply it's $2.25 per line, because in terms of the context, change in y over change in x, y is dollars, x is number of lines, so $2.25 per line. Okay, just thinking big ideas. So let's go ahead and now write our equation. Okay, we want slope-intercept form, so let's write y equals mx plus b. And unfortunately, I just have a regular old point. Okay, so we have our m of 2.25. And then we have an ordered pair. We've got multiple ordered pairs, but we have the first ordered pair that we're going to use. So I want you to substitute x, y, and m into y equals mx plus b to find b and write your equation in slope-intercept form. So upon substitution of 3 for x, 12.75 for y, and 2.25 for m, we should get b is 6. So plugging into our slope-intercept formula, y equals 2.25x plus 6. Where again, the slope represents $2.25 per line, and the y-intercept would be our initial amount, our upfront cost of $6. Okay, so we then want to find the cost of an ad that is 21 lines long. Okay, so 21 lines, that is referring to, look at my x and y, that's going to be an x. So we need to plug in 21 for x and solve for y. So y is already by itself, so we just need to evaluate. So we've got $2.25 times 21 plus 6. And 225 times 21 gives us 47.25. So y equals 47.25 plus 6, which gives us y equals 53.25. Okay, so a 21 line ad would cost $53.25. Okay, so make sure we use our unit labels with dollars here.